now we're on the record. We were off the record for a little bit trying to figure out some mic situations. But without further ado, let's get this started. Welcome back, Kennen Hutchison. Let's just go over to start. Well, you're going to introduce yourself. But if anyone's been keeping up for the past 30 episodes, you know who this is. And let's just start with saying that a couple weeks or a week or a couple days ago on TikTok, posted a clip of you talking, which is getting a little bit of attention right now, talking about the vaccines. So introduce yourself and then we'll get into that.
Yeah, sure. Thanks for having me back. As you said, I'm Kennen Hutchison. I'm a virologist, so I've been studying viruses for about the past decade, 10 years or so, and science communicator on the side. So when I'm not studying viruses, I just talk about science and how it affects our life.
So, to start out, before we even do anything, like even talk about that, have you seen with anything that you've posted just regarding COVID, regarding viruses, has been controversial on your Instagram? Because you do have a decent amount of a following. And so have you posted anything where in the comment section, it's done exactly what's happening right now with the clip?
I will say Instagram has been a great place for me, and I feel like that is not the narrative that I hear from every other science communicator on Instagram or any other person on Instagram. I would say the most controversial thing that I have seen was I made a post where I was talking about the case fatality rate and why it was important to get vaccinated and how many people. And I broke the math down, just like 1 in every 55 people, I think was the number, who was getting COVID was dying at that point. And the most aggressive things that I had were people who were like, explain your math to me. And then I explained my math like 30 times. And I was like, okay, just look previously. But
Yeah.
I looked at your post and you are getting way crazier comments than I ever get on anything that I post.
So I think I have, like I said, so anyone listening to this, I have not been on TikTok that long, but I do think that might be something, like you said, Instagram might be different than TikTok in that respect, because I have seen people argue on one of my posts before. I posted a clip of this music artist talking about what he thinks happens when you die. Controversial topic at most. And there were people doing the exact same thing, like shaming him and things like that. And so I never really got to experience people just like outlandishly lashing something I've said until a couple weeks ago before this one. People have been clipping and sending me things that I said out of context. And I was like, well, I didn't mean that. And so, but yeah, to see on my own page such a controversial argument and in a video that doesn't seem that like controversial, you were just really talking about how anaphylactic shock was happening a little more regularly. Now, disclaimer to anyone who's listening to this, I posted that TikTok 3 months almost after we had this conversation. So when Kennen was talking, he was talking from the beginning of the virus, of the vaccines. So without further ado, let's get into this. What is the updating information on the vaccines that as a virologist, not as a COVID expert, like we were saying, but what is the update of those numbers? Has there been more than just anaphylactic shock?
Yeah, I mean, so there's been some cases of adverse reactions that have gone through the system still. Yeah, you made a really good point. When we first talked about this was within the first weeks, maybe month or so of the vaccines being out. And so what we were talking about with the anaphylactic shock was that we were seeing an increased rate of maybe like, I don't even remember what the number was at that point, like 5 maybe in a million. For every million cases, there was maybe 5 cases of anaphylaxis that was popping up at the very beginning. As more people got the vaccine, we saw those numbers steady and come plateau, I guess is the word, back out to like more normal numbers of around 1 in a million, 2 in a million, which is pretty much the general rate for any severe adverse reaction. And to clarify again, anaphylaxis, while it is scary, is treatable. And to the best of my knowledge, I do not know anybody who has died from anaphylaxis from this. Normally, that's why you wait after you get the vaccine. You wait for like 15 to 30 minutes. It normally sets on pretty quickly. Get an epi shot, a little Benadryl, you're all good to go. So yeah, that is the clarification for that. But yeah, the most common side effects that people are getting from these vaccines, if they're getting side effects or symptoms, I guess, of them, are just going to be soreness, redness at the site of infection, fever, chills, body aches and pains, and just like this excessive tiredness. I got both of my doses and it leveled me the second dose that I got. I was just so tired. My body felt like I had just done like two-a-days for like a week straight that night. But then all of these symptoms pretty much resolve themselves within 24 to 72 hours.
So, like we said, this is just from the point of view of virologists, but have you seen any, or has anyone reported any deaths or any of other side effects rather than anaphylaxis from? Now it becomes controversial when we talk about Johnson and Johnson, right? Let's backtrack before that question. What happened with the Johnson and Johnson vaccine? Because I don't really know. I just know that they pulled it. What was going on before they pulled it?
Yeah, so I think that this is a great example of how attuned to the safety of these vaccines that we actually are when people are questioning safety. So what happened with the Johnson and Johnson was that out of 7.8 million doses of Johnson and Johnson that were given, there were 7 cases that were identified in young middle-aged women who had blood clots, and this was associated with the vaccine. So 7 out of 7.8 million is like less than a 1 in a million occurrence, which is pretty low. I was actually surprised that they pulled it, but it was a big enough deal that they said, hey, we need to investigate this. And so that's what they did. They pulled it out, they investigated it. They said, hey, it does look like there's an association with this. And so they said, it's not happening in men and in these other populations. So we're just gonna put a restriction or warning on it. So if you fall into this category where you have an elevated risk of blood clots, maybe don't get the Johnson & Johnson, opt for another one, but it seems to be safe for all of these other people, so let's get this back out there. So I really love that because Johnson & Johnson's like the gold standard of vaccines, right? It's 1 dose. You don't have to keep it at those super cold temperatures. It's really easy and accessible to get out to the public. And the fact that we were willing, I say colloquially, scientists, whoever, but the fact that they were willing to pause this like the end all be all of vaccines of like what we'd like to give people. And they're willing to pause it because of a less than 1 in a million rate of something happening to investigate to make sure that it's safe. I think that really speaks to how well we're tracking all of these adverse effects and making sure that these vaccines that we're giving to people are safe.
I apologize if I didn't hear you say this or I wasn't paying close enough attention. Did you say why it was middle-aged women, young middle-aged women?
I did not say, and I personally don't know. So I was telling you at the beginning of this show, when we first talked, I think I was more lumped in with the COVID experts. I was staying really up to date with everything that was coming out. And, you know, for selfish reasons, after getting vaccinated and posting everything that I could about this, I've kind of like tapered off on what I've been reading, what I've been following up on. And so more of what I'm going to say, more or less, is just going to be what I know just from what I've read, but I'm not like following completely and making sure I know every single paper that's coming out on it. So I'm really talking more as a virologist and a COVID expert here.
Yeah.
So
While we're on the subject of vaccines, I want to get back to what we're seeing, the numbers and everything. But did you see what Joe Rogan said about young people that took off in the White House? Kind of. Can you?
was this the thing where he was just like, young people should just get COVID? Like, it doesn't matter. They're not getting sick. Is this the thing you're talking about?
I think he said, yeah, I think it was more like he said, if young people, if you're like 21, healthy, eat healthy, work out, if you're 21, don't get the vaccine. So I think it is something like that. Can you say if that's wrong, why that's wrong, and what is the correct thing? Should everyone get the vaccine? I know you're saying that it is better to get the vaccine, but can you just clarify why that is wrong and what should happen with young people?
Yeah. So that is wrong. And the reason being is that the vaccine gives you protection without you having to be infected with the virus. If you get infected with the virus, no matter what, whether or not you're asymptomatic, no symptoms, or you have severe COVID, you have a living virus inside of you that's replicating. And every time it's doing that, it's killing cells, it's doing damage. And we know the effects of this virus. We don't know what all of the long-term effects could be. You could be asymptomatic and still have effects that show up later down the road because you had a live virus that was doing damage inside of you, even though you didn't know. So it would be much better to get the vaccine to generate that protection than to expose yourself to a virus and say, I'm young and healthy, because this virus, it affects your cardiovascular system. So we're seeing reports of men having erectile dysfunction. We're seeing reports of increased strokes. We're seeing reports of it affecting the brain and links with Alzheimer's and things like that. And so on top of it already attacking your respiratory system, which is what we commonly think about this, right? People getting vented. But it's not just stopping there. It's able to infect all sorts of places in your body because you have that receptor ACE2 all over. So if you have the decision, the option of being like, am I just gonna think that I'm young and healthy and like risk getting an infection that I don't know what's going to happen? Or would I rather go and get a shot or two shots where I'm not going to get infected by this virus and then I'm going to have protection in case that virus comes in, so it doesn't like do as much damage to fuck me up as much as it could if I was unprotected.
So now that we know, because I remember I backtracked about the Johnson and Johnson. So now that we know that that was the Johnson and Johnson, why they pulled it was because of the seven women who had the blood clots. Now let's go to just the vaccines in general. So mainly Pfizer and Moderna. Have we seen any deaths, any other forms of autoimmune disorders? Because remember they were talking about lupus. Did that happen? Was it not a causation? Could it have been a causation? What have we seen, to your knowledge, with these viruses or vaccines that are not that common but still happened?
Yeah, I wish that I could give you a more in-depth like synopsis of all of the, and when I say all of, like probably the handful of random things that happen. So there's what is that? Thrombocytopenia, I think is what it's called. So you see this really drastic decrease in your white blood cells, and this can be dangerous. I know I've heard of some cases of this occurring after the vaccination. Again, very rare, and you got to keep an eye out on that. What are I don't know off the top of my head though. I guess there's not been a lot of really prominent things that have popped into my news feed, at least of things that I've been like, oh, I should be more wary of this, at least in what's coming along. This is not very helpful to what you're asking. I feel like.
No, it's okay. That like we said, this is more of a virologist talking to me, not really a COVID expert. But can we just talk to the people for a second and myself and explain to us from a virologist standpoint why it is more important to get the vaccine? Because you did say that COVID, we have all these complications with COVID that we don't know down the line. But disregarding COVID, why is it more important when we do have a vaccine to take a vaccine than it is to get a specific, because they do range from all different things, all different types of diseases, all different types of sicknesses you can get. But why is it important to have vaccines, and why are vaccines important?
I mean, plain and simply, if you want a soundbite, it's vaccines save lives. So you can very easily go in Google and look up things like, I don't know, diphtheria or polio, smallpox. I mean, even the flu, you see the decrease in that. But you can look at the rates of these diseases that we used to have: measles, mumps, pertussis, and the people that got really sick from these, the people that were dying from these before the vaccine era. And then you see the introduction of vaccines, and you see these diseases just almost disappear. I mean, there's still sporadic cases that you'll see, but in the best case scenario, they're completely gone. Smallpox is like our promised child, and polio is thought to be gone by next year. So polio pretty much just pops up in like India. I think there's a small population in like maybe the Southeast China, Middle East area, because there was a scare around the polio vaccine, the live attenuated one, like causing polio in people, which may doesn't matter. It doesn't do that. If it's not inactivated though, you can have problems. And so there was a scare around that. And so there was this anti-polio vax movement that allowed polio numbers to start coming back up. But then as polio numbers started coming back up and people who were unvaccinated, they realized, oh wow, the vaccinated people aren't getting polio. Maybe I should get the vaccine again. And now we're seeing people taking vaccines, and polio will probably be gone from this planet in humans. Definitely, the WHO thinks by 2022. I would venture 2025 is a safe bet. So within the next 3 to 5 years.
So with something like polio, so go back to our conversation last time about viruses. This is a weird hypothetical, but let's say in a world where we wipe out measles, we wipe out specific viruses, HPV, COVID. Is there a chance that a new virus comes around that's almost identical to that sickness, but generated itself almost completely by itself? Like not having any relationship to COVID, could another COVID come along and do just the same thing?
Uh, in a way, I mean, I'm not going to say like a new virus is just going to pop out of nowhere. So there's a long, viruses have been around for as long as DNA has been around. So probably since the beginning of time, it was like the first cell popped up and then the first virus popped up. And so there's lots of different viruses. So let's say in this hypothetical that we completely get rid of SARS-CoV-2, which is this current coronavirus that's causing COVID-19, right? So it's completely gone. It is very likely that at some point, whether that's in our lifetimes or in the next 10 generations, there are hundreds, if not thousands, of other coronaviruses that are out there. It is very likely that another one will pick up a mutation, end up coming into humans, and can cause another pandemic. We've already seen this happen twice in our lifetimes. So SARS-CoV-2 is its own virus, its own unique virus. But in 2004, we got hit with the very first epidemic coronavirus, which was the original SARS virus. And then fast forward, 8 years later to 2012, and we have MERS, Middle Eastern Respiratory Syndrome, Middle Eastern Respiratory Syndrome virus, which is another coronavirus that jumped into camels and started causing a small epidemic. And so we have these outbreaks. So this is our third coronavirus outbreak in our lifetime in the last 20 years, which is pretty crazy. So it's not crazy to think that within the next 20 years, there could be another one that pops out.
So COVID numbers, what are they looking like from right now, from what you know of? Is it looking like the vaccines are helping a lot, helping a little? And do the vaccines, this is a compound question, I'm sorry, but do the vaccines actually stop you from getting sick? Because I think there's a question I have that some people think that the vaccines stop you from getting sick, and some people think that the vaccines stop you from dying. Which is the case? What are the numbers looking like? And what does the vaccine actually do?
Yeah, a lot of questions tucked into there.
I know, I'm sorry.
No, you're good. So numbers are looking better. Numbers aren't fantastic still, but they're way better than we were seeing back in November, December, like post the holiday season, where we had a lot of people that went out. We had a huge spike in cases. We kind of saw that third wave in the United States. We're back down to pretty much early pandemic numbers. I think the last I checked, maybe I could pull this up. I think we're at like 30,000 right now. Let me double check. Having real numbers is always better. Yeah. So yesterday, reported new cases were 25,000. So yeah, less than 30,000. And this is in the United States. And we had 400 deaths. So those are good numbers. I mean, particularly comparing that we were having like 50,000, 80,000 cases per day, right? We're down to a more manageable number. The real risk was really overrunning our hospital systems with that, and we're not at that, pushing those bounds right now, which is great. And that does seem to be correlating with vaccinations as well. So the only caveat that I'll throw in there is, while we know that vaccinations are going to help with decreasing this, which we'll get to that last question that you asked, we also know that we saw a dip in the numbers occur around this time, spring. More people are starting to go outside, right? So outside, the virus is seldomly going to spread to people. Just by nature of having air to dissipate the viral particles, you're going to have less infection, be exposed to less infectious particles. So as people start going outside more, start socializing in less crowded spaces and indoors, we see this kind of dip down. And so it's the way that we'll really know is when we saw that second wave that started coming around the summer holidays, when people started doing stuff together again. The hope is that we're not going to see that. And that will be a result of, at this point, around 50% of Americans at least have one dose of the vaccine, and 40% of Americans have both doses, are fully vaccinated. So if we keep that trajectory, the goal is that we might still see some residual COVID that's happening, but we're not going to ever see those numbers that we had over this last year.
Yeah, and as we say this is the week before Memorial Day. So it seems like the numbers are going to be showing in like, what is it, 2 weeks? And then you'll know, 14 days.
Yep.
Dang, I had a question for you, but we can just disregard it. Yeah. What are you going to say?
Well, I was going to say, I can follow up on the
vaccine question. Yeah, do that.
Yeah. So you're asking, the last part of that question was what's actually the point of the vaccine, right? Is it to stop me from dying? Is it to stop me from getting sick? Is it to stop me from spreading the virus to other people? What does the vaccine actually do? And so at this point, what we could say the purpose of the vaccine is somewhere between that stopping you from dying and stopping you from getting sick. So we say stopping you from getting seriously ill. So the main purpose of this vaccine is that it's going to prevent you from needing to be hospitalized. So it's still possible that you could get infected with COVID. We call these breakthrough cases. So when you're vaccinated and you still end up having getting COVID or getting infected. But the idea is that we want every infection to just become like asymptomatic or a common cold, so that nobody really cares about it. You don't care about the cold. You're not hearing CNN being like, go get vaccinated for the cold every cold season. And that's what we want coronavirus to get back to. There's 7 coronaviruses that infect humans at this point, and 4 of them just cause the common colds. And we're trying to make this one down to 5 of them being common cold.
So I'm sorry for these controversial questions I'm throwing at you, but they fascinate me. And you know, I think a lot of us, the good thing that we're doing here is a lot of us sit here and we don't have a virologist friend to talk to. A lot of my, you know, and so like from to seeing things that we hear from other people just spit out, because you know, I think a lot of this, regardless of anyone's beliefs, is a lot of the people higher up right now are very polarized, and so they feel like they have to say one thing or the other. So when someone says, because I did hear this, and it does make sense. We talked about this last time. A lot of the deaths come from comorbidities like obesity in America, and we do have a problem with obesity in America. Are we seeing? And a lot of the arguments that we're hearing right now is that there's not enough about staying fit and healthy, because people are like, get vaccinated, go have Bud Light, or go get Chick-fil-A or something like that. I remember a governor saying that. Do you think that we should be pushing more health and well-being as well as the vaccine, or do you think that right now it's more important to talk about the vaccine?
Well, I mean, it feels like a loaded question, because the answer is obviously yes. You can't,
Yeah.
how can you speak about health and well-being without talking about health and well-being, right? So having a healthy lifestyle, making sure that you're in shape, all of these things, they're not specific to COVID-19. They're just general to having a healthy lifestyle and being a healthier person, right? If you have a immune system that's already high functioning and your body's not fighting off things like diabetes or emphysema or COPD or anything like that, right? That's more resources to focus on keeping yourself healthy. And that every doctor that I know of in the world is going to tell you that that's a good thing, right?
Mm-hmm.
I can't imagine a single doctor that's like, you should definitely sit on the couch, get to like 500 pounds, eat potato chips, and like you're going to be healthy.
Yeah.
So yeah, that's just a general conversation. I think when it comes to this pandemic, right, the talk is definitely on what can we be doing as preventative treatments. Vaccines are number one. Vaccines are a natural way to protect yourself against a natural infection, right? So it's not like some like crazy medicine like insulin or ibuprofen or something like that. It's a piece of a natural virus that's going to allow your body to do what it's meant to do and generate protection against you. And that's a great way to start protecting yourself. Living a healthy lifestyle, taking your vitamin D, that's also going to help, not as much as a vaccine, because a vaccine is specific to protecting you against coronavirus. But it's going to help you to, even if you do get sick, to hopefully get over these things quicker. The last thing I want to say on that, though, is that I work here at a hospital, and we've got a lot of friends who are in the emergency room and see patients on a daily basis. And, you know, we kind of think of this as black and white. It's like people with comorbidities, old people are the ones that are getting really sick. But I hear all these stories, and I have pictures in my phones of all of these lungs of young, healthy people who are in their mid-20s to mid-20s to mid-30s who don't have these comorbidities, who are still being hospitalized about this. So it's not like there's a magic number of if you're young and healthy, you're immune to it. You know, you never know if you've got some underlying genetic condition, or if you just get a high dose, or you get a variant of that virus that came from someone that's going to just put you out. And so why take a risk when you can have an action that protects you, which would be the vaccine?
Has there been any studies on whether the people in the young 20s, when they get something really bad in their lungs, has to do with the vaping epidemic that we're seeing, and how, and I don't know if you know that answer, but I was thinking of that when you were talking.
No, that's a great question. I don't have the answer to that. I would love to see the studies that come out on this. Yeah, smoking, for what it is it's not great. You don't want to be inhaling anything into your lungs. It affects your cardiovascular system again. Actually, I was just hanging out with my friend who's a urologist last night, And he was talking about this again. Erectile dysfunction, I feel like, is a way to scare any guy into doing anything.
Yeah.
Yeah. And so he was telling me about like, so luckily it's like fairly reversible if you, as long as you stop smoking. But like the biggest cause of that in young men right now is smoking. And so and that's because it's breaking down your blood vessels. And so this virus is already attacking your blood vessels. So vaping, smoking, anything that's going to cause damage to your lungs, damage to your heart, damage to your blood vessels is not going to be great. So I imagine when those studies come out, there's probably going to be some correlation, but at this point, that's all speculation.
Going off a little digression, I think it's all about habit. Everything that we do is about our habits. It's so easy for me to fall into a habit where, especially if I'm not in school or I'm not playing football or I'm not like really engaged in something working, if I'm on vacation or like I have some time to just like relax, it's really easy for me to fall on the couch, eat potato chips, hang out, drink a couple beers every night and not work out or go, do things. But then if I like, all right, I'm going to eat like this and I'm going to start working out. Really, if I start working out and I work out consistently for 2 to 3 weeks, 5 to 7 days a week, because I like playing basketball and stuff. Like I saw your, shout out Kennen, he can dunk. Yeah, I like staying a little active. And if I get in that habit, it's really easy for me to stay in that habit. So I think it's all about, if we could find a way, and now COVID kind of put a little shutdown on going outside and hooping and stuff. But now that everything's opened up and stuff, if we could find a way to get it really instilled in people's minds, just try a habit, a good, healthy habit for a little bit, I feel like it will be easier for people to consistently do it because it is, especially exercise. It's so rewarding to you. If I don't get a workout in when I know I should have worked out, I feel like shit. And I know everyone else feels like that. I bet you do too.
Yeah. I mean, when I am in a habit of working out, for sure, I feel like guilty when I don't work out. Building habits are hard though. There's a ton of books. There is, what is it, 8 ways to build a habit or something like that. It's like I was just recently reading that, and High Performance Habits was another good book. I don't know. The hardest part about it though is like building that habit, right? You have to have the drive, whether that's internal or external. If you're talking about exercise, to go to the gym or to do your workout every day. And that's just one aspect of it. I think while I'm always going to promote working out and having a healthy lifestyle, sometimes it's hard for people. Like imagine being a single mom who's working 3 jobs in order to make sure that her kids have all the resources to go to school. How do you fit in gym time in there, right?
Yeah.
Or what if you live in a neighborhood where, getting access to the gym isn't necessarily the safest place and you don't have a backyard to run in, or you live here in the city and like there's not a lot of green space for you. So it's easy to be like, yeah, I wish everybody would do this, but you always have to consider like not everybody's as fortunate as us too. And so how can we make building these habits more accessible to everybody?
And, there is something to be said about people who are staying fit, recency bias. If you're going to the gym, working out for an hour to 2 hours a day, lifting heavy ass weights, it will easy for you. Like, why doesn't everyone do this? But I was recently listening to a podcast with Ethan Suplee and Joe Rogan, the dude who was like 500 pounds. He was the dude in, Remember the Titans, who was really fat. And then he got really like jacked, that guy. And he was talking about, it's all about what you can get yourself to do. If all you can do is get up and go to your car or get up and walk to the mailbox, then that's what you got to do. And so I think, and what I will say that I disagree a little bit what you're saying is like, yeah, a lot of people are fortunate, but I do think that a lot of us, especially in America, now the single mom argument is a very good argument, but I feel like a lot of us have time we can fit in, but we'd rather be comfortable in those times. We wake up, we get in our phone, we lay in our beds for 30 minutes. When all you can do, you do some push-ups or do some squats. Everyone can fit in a little bit of time. And I think that, I'm totally victim of this. It's that when you're comfortable, when you're so comfortable, because our beds are so comfortable, our cars are so comfortable, everything's like, we have Xboxes, we have laptops, when we like allow ourselves to become so comfortable, it's really hard for us to build a habit, like we're saying. And I think that's one of the reasons why building habit is so hard, especially like working out, because does take 30 to an hour. You know what I mean?
Yeah, for sure. I don't disagree with you there. Yeah.
But, back to, you being a virologist and everything, I saw, not too long ago, I can't remember when, you were playing with, you weren't playing, you were working, but you had Dude, what is it called? It's the ice that like you
Liquid
touch it,
nitrogen.
liquid nitrogen.
Yeah.
And I
Yeah.
was so fascinated. I was just clicking through every story, and I was like, what? Because what exactly were you doing with the? I know the liquid nitrogen was for viruses, right? But what exactly have you been doing in your labs? Have you been infecting things, seeing how viruses affect certain brands? What exactly have you been working on lately, especially the liquid nitrogen? Because that blew my mind.
Yeah, so that was those were actually cells. So liquid nitrogen is just really cold. It's like negative 321 degrees Fahrenheit, which is just ridiculously cold. So I was doing something called snap freezing. So I had cells that I had proteins inside of that I wanted to see what was happening with these proteins. But it was like a Friday night. I wanted to come back and like chill with my people. So I was like, all right, I'm gonna wait and do this on Monday. So the way that I can save all of those proteins exactly how they were was I just threw them in that liquid nitrogen and it like instantly freezes them. Like think like sub-zero, like just like frozen in motion. And so that's what the liquid nitrogen did. So it froze them. Then I stuck them in a freezer at like negative 80 degrees Celsius and let them chill over the weekend. And then I was able to work with them this week. So that's what the liquid nitrogen was for. What I've been doing in the lab is my lab is a herpes virology lab. So we study herpes viruses, which are crazy viruses. They're
Yeah. Oh, you know
nobody
what?
wants.
Real quick, I didn't mean to interrupt you, but since you study that, like since you're working on that, let's let's talk about herpes because I don't think a lot of people. I think we got into it a little bit last time. But what exactly is herpes, and have you been working like? Then we can get into what you've been doing in your lab. But let's just take a little backtrack and what is herpes and why are they so fascinating? Because I'm fascinated by them too because I don't want to get them.
Yeah, I mean, the sad thing is, or not the sad thing, the reality is you probably already have at least one or two. So herpes is just this large family of DNA viruses. Um, and they're pretty much characterized, like one of their main traits is that they stay with you for life. So there are three different families of them, which aren't really that important: alpha, beta, and gamma. And you can break those up by like where they infect you. So we study the alphas, which I'll get into in a little bit. But there's 8 human herpes viruses. So you have herpes simplex type 1 and type 2, which most people are familiar with. So herpes simplex 1 is normally what you think about for cold sores. And then type 2 is normally what you think about for like genital lesions, like the STI, although you can get them interchangeably. Then there's varicella zoster virus, which is the chickenpox virus. So the virus that causes chickenpox is a herpes virus. And you get that whether you've ever had chickenpox or the vaccine for chickenpox actually uses what we call is a live attenuated virus. So it's a live virus. We've just genetically changed it so that it's weak, so it doesn't give you chickenpox, but it still has the ability to do what all 3 of those viruses can do, and that's hide out in your nervous system. So that's why I think that they're really cool is herpes simplex 1, 2, and varicella zoster virus, the chickenpox virus. They all, when they infect you, normally you don't even know the first time you get infected, but they get into your nervous system, which there's 2 parts of your nervous system. There's your peripheral nervous system, which is what allows you to like move. So like if you like pinch your finger and you feel that, what's happening is that pressure on your finger is sending a signal down these neurons that go on all the way up your arm into your spinal cord. And then they send a message from your spinal cord up your brain stem into your actual brain, and your brain and brain stem are what's your central nervous system. They're the ones that process things. And so the herpes virus, when it infects you, it'll go into those peripheral neurons and go and hide out in the little ganglion that are like right next to your spinal cord, but they normally don't jump into your spinal cord. And that's where they stay for life. And then sometimes things like stress can cause them to wake up essentially, and then they'll come right back out. And so if you get like a cold sore, they go and travel up right underneath your brain. And then if you get stressed, they'll travel right back out, and then they'll start reinfecting the skin cells. And that's when you get a cold sore typically. And this cycle happens over and over. And that's why herpes is for life.
That is fascinating. So, okay, yeah, because I've gotten cold sores, and so here's my question: I used to get cold sores all the time when I was younger, and now I don't get any of them. Why does that happen?
I mean, there's a lot of reasons. That's a very active part of herpes virology research. If I was to throw out just a rough speculation with some evidence that could go along with this, but this is by no means concrete. When you're younger, your immune system is a lot less defined. You're still learning and like building a stronger immune system. This is also why like we have to test vaccines separately for kids than for adults is because they have a more immature immune system. And so as you get older, your immune system becomes more mature, probably more capable at just like being able to keep the virus at like this latent state is what we call it. But, you know, things like sun or just stress or things like that, lots of different factors can cause them to reactivate. So once you have it, it's always there with you. It's your best friend for life.
So when you say that they hang out next to the spinal cord, but they don't jump in, what exactly happens if they do jump in?
That's you're feeding me right into my research.
Let's go, man.
Yeah, so that's one of my projects is I study this disease called herpes simplexencephalitis. And so essentially that's what happens when the herpes virus doesn't stop at that point next to it, and it jumps in and goes up to your brain, and it causes swelling in your brain, and this often can kill you if not treated. Luckily, we have drugs like acyclovir, valcyclovir that can help, but normally it causes brain damage that's often irreversible, has some long-term effects with it. And so we don't know exactly why that happens. It happens in a really small percentage of people, like 0.0001% of people who have herpes simplex 1 or 2 will end up with herpes simplex encephalitis, those infections in your brain. And one of the projects that I'm working on is we've discovered with our collaborators out in New York, this most often occurs in kids. So when you have like a newborn baby, if the mom gets herpes for the first time, as they're delivering the baby can get in the birth canal, and they can be susceptible to this. And we found that there's actually a genetic link. So there's this small percentage of people in the world who have these mutations where their brain cells, their central nervous system brain cells, don't have this gate anymore to block the herpes from getting in. And so then it's just like, oh, come on in, which is really dangerous. Or the majority of us, 99.99% of us, have this functional gate, and the virus just seems to not be able to get into those cells, so it just hangs out.
And when you say, we always talk about like 0.001% of people, but isn't that still like, let's go America alone, like 100,000 people or 10,000 people?
0.0001%. I think it's like essentially like 1 in a million, and there's 330 million people. So I think that's what, 33 people in the United States, 33 cases.
You said I missed.
Is that right? Maybe I'm doing that wrong.
Wait, all right. Let me just do it.
Yeah.
Let me just do the math.
This is why I went into biology, because computers could do my math for me.
Listen, my last episode, we were trying to do like every person you know is like say everyone knows 100 people, and we were trying to do that math, and we just could not do it. Okay, times point.
Oh, I'm an idiot. If it's 1 in a million, that's 330 people.
Yeah. Okay.
Yeah.
God, dude, everyone listening to my show, there's this one part where we're just struggling with math. I should just call this the struggle with math show. But
yeah, so like 330 million people in America, I guess, if you're looking at 0.001%, will have HSE. So very low in terms of like all the people, but also who wants to have a infection in their brain?
Nobody, hopefully. Some people might be weird, but no, I'm just kidding. But you said mutation, and it got me thinking about something I heard yesterday. Because remember, we were talking about mutation last time, and I heard that have you heard of the drunken monkey hypothesis?
Yeah, for why our acetaldehyde or our alcohol dehydrogenase, the protein that allows us to like break down alcohol, is so functional so that we don't die when we drink alcohol and we have a good time.
Yeah, because I was watching it. I think it was a clip, and it was saying that like when we started coming down a really long time ago, one of our ancestors, when we started coming down from the trees, one of them had this mutation that would let them eat the fermented fruit that fell from the trees and was on the ground, and it gave them extra calories. So in the long run, it helped us, and that's why we can get fucked up basically and have a good time now.
Science for the win. Yeah, the reason you can get drunk and don't die as soon as you start drinking alcohol, all because of a mutation.
Well, and it made me think about what we were talking about last time too, because like basically all the greatest, like not all of the greatest, but a lot of the good things that we attribute to being a modern human today can be tracked back to a mutation that wasn't like that common in our ancestors.
Yeah, I mean that's evolution. That's the whole basis of evolution, right? Evolution typically doesn't happen to not typically, it doesn't happen to a person. Essentially, you have a mutation that has a benefit, and if that benefit allows you to essentially live longer and correlates to you having more kids, then your kids are going to have that mutation, and then eventually, like the population with that mutation grows, and all of a sudden you have this whole new people who have this mutation in there, and if you get enough of those and you can create completely new species, and that's how the world works.
Yeah, at least this world. That's dude, it because it really puts everything like when you're learning evolution, you're probably in third grade or something like that. So it doesn't really stick with you. And so like when I was watching that, it took drunk monkeys for me to understand what really like what everything that I was learning from the whole time. But to go back to like uh STIs and things like that, like herpes and what you're studying. A question I have for you is that is the reason that STDs and STIs are so prominent through sex is because of that how easy it would be because it is two bodies mixing together because you would think about it as like viruses go in through probably through the respiratory system or and some viruses go through sexual intercourse. Is that because some viruses you can't get from oral sex and you have to get it from intercourse? So it's like why does that happen? Is it because of it's like mixing of two, like is it because of the fluid? Is it because of it has to be like severe touching, it has to go in the bloodstream? How does that really work? I mean, you know, if you don't know it, I understand, but why does it work, or why are sexual diseases so prominent in humans?
Yeah, I mean, I guess first of all, I'd take a step back and put it in perspective. I wouldn't say that they're super prominent. I think respiratory viruses are super prominent in humans. You also get viruses from eating things, right? If you eat contaminated food, it's essentially any time that you let something outside, we call it a pathogen, something dangerous, get inside to what I'd call like your mucosal cells. So anything that's slimy, essentially, like you're giving it access to the inside, and that's where you're at risk. But yeah, when it comes to STIs, at least, I think just as humans, sex has always had a thing around it, right? Like people are fascinated by sex, and like that either like makes them become like hypersexual people where they're really interested in it, or it like pushes them the other way and you become like super like churchy, and like there's a whole taboo that's built around sex and everything. So like it's just really fascinating. So when it comes to STDs, then that it's already something that people want to engage with and probably sticks in their minds more so than say the cold, right? Which is super prominent, way more prominent than any of these STDs. Um, but with one of the other things you were talking about was like transmission. And so, when you're having heterosexual intercourse, right, you're going to have a dick going into a vagina. There's a lot of mucosal epithelia in there, and you're pretty much just sticking a rod. Hopefully that rod is clean, but if it's got some sort of disease on it, some sort of bacteria or virus, then you're just sticking it into one of those mucousy surfaces, right? And you're like just like hand delivering a disease up in there, right? So that's one reason why it's more prominent. The other reason, though, is that, and this is particularly when you think of like HIV, so not just with heterosexual sex, but with homosexual sex too. So with guys, one of the big reasons and the big risk of like anal sex, I guess, is that your butt's not naturally lubricated the same way, and so you get a lot of these things called micro tears. So you're as you're actually having sex, and this happens in the vagina too, but you get these like little cuts essentially from friction and from rubbing, and essentially those little cuts are openings for outside things to get in. And so unlike if I were just like kiss you on the forehead, you're probably not going to get herpes on your forehead. But if you have a cut on your lip and I kiss you and my virus is able to get into there, now it's gotten past your skin already. It's gotten past a lot of the defenses that your body already has to keep these things out, and it's got a quicker access to establish that infection. So I would say that might get towards like the answer that you're looking for.
So is it just because of the micro tears why HIV is more prominent in gay, or was more prominent in gay men than it was in heterosexual sex, or was there another reason?
I wish that I knew the full story to that, so I can't really comment on why it's more prevalent. I think that there's a lot of factors that go into that, but that's definitely not my area of expertise and falls more into like epidemiology research
Yeah.
than the virology of HIV.
Yeah, and just go back to viruses. So last time we were talking about sexual or not, we were talking about um, HIV. We were stemming. I think we went even to malaria at some point. But what is right now? What is a virus that just fascinates you? That maybe we still don't understand. Maybe you do know a lot about it. But what is a virus that fascinates you? That's maybe ongoing today or hopefully extinct? Just anywhere from those.
Rabies is my favorite virus, hands down. Rabies is a crazy ass virus.
I remember you
uh,
telling me that like 99.9% of people die with rabies, right?
yeah, if left untreated, that virus will like mess you up. And I think I did this last time too. I'm pretty sure the answer is five. Does
Yeah. I remember you saying something about this, but remind me. The five, it's like letters, right?
No, so proteins. So humans
Okay.
have, I just want to make sure. Yeah, five. All right, it is. So humans have like, there's 23,000 proteins that are each, you can think of a protein as like a little worker inside of your cells that does a job. So
Mm-hmm.
to make you who you are, to have blue eyes, to have the color hair that you have, all of that, there's about 23,000 proteins that it takes for you to function. The rabies virus has 5 proteins, just 5. And this thing is microscopic, tinier than your cells with only 5 proteins, and it will kill you nearly 100% of the time that you get it if you don't treat it. And it just blows my mind. That's the first cool thing about it. And then all of the symptoms and side effects of how it works. Rabies is thought to be the disease is probably what stemmed werewolves, the idea behind werewolves, right? So you get bit by a rabid dog, and then one form of rabies is that once it gets to your brain and causes all this swelling, it kind of represses your frontal cortex that allows you to act like a normal human, and you kind of become a little bit more animalistic, and like you also become very delusional and crazy, so you like lash out, and then the virus goes into your salivary glands, which makes you like start
Foam.
foaming. It also since it's replicating in there, it swells your throat up, so your throat hurts really bad, so you don't want to swallow, which is why if you've ever heard like some people with rabies, they're afraid of water. It's not because the water's scary, although that's a fun like mythology thing. It's actually because just looking at water when you're really parched, you like just seeing water, like you swallow instinctively, and it hurts so bad that they don't want to look at anything that's going to make them swallow. But so like you have these people who are afraid of water, who are acting kind of crazy, kind of delusional, and then the virus spreads essentially from your saliva. So I don't think it's super common for humans who have rabies to bite other people. But if all it takes is one person who's like foaming at the mouth after being bit by a dog, and you're like, wow, they're turning into a dog, werewolf.
So how? Because I didn't know that you could treat rabies after you were bitten. How do you treat it? Is there a specific time that you have to get treated by?
Yeah, so rabies is another thing that makes rabies cool. It travels from in your nervous system also from neuron to neuron. So essentially, however far the bite is that you get for rabies. So if you get bit in your finger here, the virus has to travel from your finger all the way up your arm to your brain. And once it's in your brain, you're pretty much screwed. I don't think there's any treatment at that point. And so if you get bit on the face, though, it's a lot shorter trip to get to your brain. So depending upon how far away is how much time you have, which is why if you get bit by an animal that you suspect has rabies, you should go in instantly. And what they do is they give you the vaccine for rabies, and then B, they give you a cocktail of antibodies against it. And essentially, since the virus takes a while to like travel throughout your body, that is enough that those antibodies are able to stop the virus from getting to your brain. So long as you treat it before it makes it to your central nervous system, your brain or spinal cord, it is very treatable, which is great. But if you don't catch it, it is very not treatable, which is not great.
So talking about rabies, it makes me think of first off, that is fascinating that's where maybe we think where the idea of werewolves came from. I had no idea. But it also makes me think of shoot, where did my question go? I was thinking of another human to animal virus. I lost me. Let's go back to COVID for a second. I'll remember it. I will. COVID, it seems to me that COVID is almost out the door. Okay. And like you said, if we see not a jump like we did last time with these holidays or even into the fall season, that it will be a good indication that it's going to become like a common cold, you know? Why? So a big question around it was it ever as bad as we thought it was? Like you said, you have friends who work in the ER and they're young people. Was it ever as bad as we thought it was, or was it blown out of proportion in your mind as a virologist?
Yeah, I think it was work. I mean, there was definitely a lot of people yelling really bad, but I didn't realize early on in the pandemic, because I was staying home and not in the hospital setting until I started working with the people who are in the hospital settings, how actually bad and terrifying it was. I think it was really bad. And there was a point where, again, I live in the city. It's different all around the country. The United States is super diverse. So if you live in rural areas, like maybe back where I grew up near Iowa, the hospitals weren't at this point, but there are definitely places where we were reaching capacity, which is really scary, because then not only are you having people who are sick and dying from the pandemic, but you're going to have people who are sick and dying from other things because they can't get access to treatment. And that's really scary to be at that point as a country. So I do think that with all the people that wanted to downplay things, that it, unfortunately, because of HIPAA things and stuff like that, you can't just take a camera into the hospital and show what's going on. But the stories from the hospital and what was going on there was scary. And this pandemic was big. I mean, 500,000 people, more than 500,000 people, almost 600,000 people have died from this year. That's a huge point. The CDC tracks how many people die each year, essentially, and they break it down by causes. There's like this really morbid thing, which is like the estimated death value. So like how many people are going to die each year? Like this is the predicted number. And you can look at the website and like essentially the pandemic kind of started and then all of a sudden there's this spike and we just exceeded. There's so many more people who died this year than we even predicted. And like that number was normally, that threshold is pretty high. So like we built in a cushion and it surpassed that cushion. And we just saw a lot of people dying this year, which is really unfortunate. I mean, people are going to die, but I don't know, as a human being, especially as a scientist who like dedicates their life to studying things and developing treatments so that we can avoid this, it's really sad that this happened. And anybody who died because of a poor decision, I think it's really hard.
Yeah, it makes you wonder because now the thing is, we did talk about this last time too, is that we it seems as though with the more deadly pandemic viruses, they're less transmittable, right? And so there's this almost like if it's more transmittable, it's probably less deadly, but it still kills people. And if it's more deadly, it's less transmittable and it still kills people, right? And so it makes you wonder, like, is there a better way we could have handled this? Was staying at home the best option for everybody? Because, you know, while, it's unfortunate and 600,000 people is a lot of people for the United States. But now on top of it, you got to think too, the economic downfalls that a lot of people had to sustain. And we're not hurting Amazon. We're not hurting Walmart. We're hurting mom and pops, which is who we would want, to help the most. And so there is this little almost like, is there a better way we could have handled COVID? Do you think there was?
Yeah, I do. I mean, hindsight's always 2020, right?
Yeah.
But I think people would not have really appreciated the approach of what I think is the best. But I think the two things that our biggest shortcomings first in handling COVID was our messaging. It's very confusing. It wasn't always the most clear or the most honest and open. And I think that ended up leading to the second problem where it became political, but it also just became, people started not trusting the public health sources and either having to turn to other sources, which were either political sources or non-expert sources, or to trusting their own thoughts because they're like, well, the CDC tells me I don't need a mask, and they say I do need a mask, and then they say I don't need one. Like, they don't know what they're talking about. So I'm either going to listen to so-and-so over here, or I'm just going to go with what I think is my best bet. And that all stems from just poor messaging. I think that, again, this is just my opinion, completely my opinion. I think that had we really locked down in the beginning, just like really just shut down, had the stimulus funds that we did so that we could make sure that people could stay home, right, and could afford things, so that we had this under control, and then took that time of while people were at home to assess what the best plan was, and had consistent messaging and consistent strategies for reopening, not based on what the whole country is, but if your county has this many cases, then you are in this tier and this stage, and you can open up this way. And if we just had a consistent messaging across the United States, rather than, you know what, let's let the states take care of this, and, you know, we'll see what happens over here. There was just a lot of chaos around this. And I think that that was what ended up leading this pandemic to drag out longer than it should have. I mean, we've seen it in other countries. We've seen South Korea, we've seen even Germany, how they handled this. And Australia is another good example of when they used different strategies, how they were able to open up a little bit earlier. And so I think that's been the biggest downfall that I saw around all of this.
Yeah, it is unfortunate. And, you know, one of the problems with that approach, like we probably should have, but one of the problems is you can't enforce martial law in a pandemic, or you can, but we haven't done it except for times of war. And there is something called the police powers of the states, for the states to decide what's best in the health and welfare of their citizens. And so under the specific republic that we have, states to federal government, you know, states get to decide what's the best health and welfare for their citizens. And so I don't think we have the power, the federal government, to do so. And that is a problem when we have a country as big as the United States, when we have 50 different specific states, because like you said, like there is a difference between New York and Alaska, right? But if we would have had a national mandate, it wouldn't have been a problem in New York or Alaska. You know, I feel like it would have been better. But then it gets back into the whole thing. It's like we've printed a lot of money and we've been giving out these checks. And if we would have shut down, it could have been a different story on the back end. But our government system is set up in such a way that it limits so much power to one direct, you know, branch of government, basically. So it's almost like it happened the way it had to in the United States, and it's unfortunate, you know?
Yeah, no, I don't disagree. That's why I said people would not like the approach that I am pitching, because essentially I look at this from a scientist viewpoint, and like what would have been the best way to eliminate this pandemic, essentially, and to like mitigate risk and damage. But that's in a very fantasy world where politics don't exist, right? And you have to operate in the political system that we are in. And again, I can't just, if it was Kennen's world and I just had martial law and I was just like, all right, this is what we're doing. Everybody stay home. Don't worry. Your bills are covered. Like, just stay the hell at home for like the next month and a half. And then we're going to be cool. And then during like the summertime when things are lower, what we're going to do is, this is what really irked me. I have a lot of friends who are teachers, and I also work in the school system a little bit. It's just like a lot of schools just had really terrible plans for how to interact with students and bring students back. And it's like, what were you doing all summer? Did you just think that this was going to disappear? So I would have had a hard shutdown to really limit the amount of spread up front, use that time to assess what is going to be best, and make a tiered system for what is the best strategy for reopening. And not just everything opens back up, but when we're here, like, this is a safe level for things to be happening. But if we start seeing cases hit this number, we need to implement these things countywide, statewide, countrywide. These are the rules that everybody should be following, and then leave it up to the states to implement those. But again, not a feasible thing in this world that we live in.
So another question that goes along with limiting viruses in general, and along with shutdowns, is masks. Now, the thing is, I feel like not all the masks work the same. You know, you walk into a grocery store and you see someone wearing a bandana that I feel like doesn't do anything, and then someone wearing like double masks of N90s, and you're like, well, that does a lot. So like, what is there a limit to what masks can do, and is there a limit to what different masks can do?
Yeah, there's lots of studies out there that have looked at just the different types of fabrics that are used for masks, the different types of masks that are out there. I mean, the main thing that hopefully everybody knows at this point is that the main purpose of masks is to prevent you from spreading particles from yourself. It does work, but not as effectively at stopping particles from coming into you. Um, but yeah, I mean, I was just at the store the other day and there's two guys that had bandanas on. I'm like, bro, like we're a year, almost a year and a half into this pandemic. Like, how you not have a real mask at this point? Come on. Um, at first, yeah, just doing anything to cover your face is it's better than nothing. But yeah, just having a standard mask at this point is that's all I have to say on it. And honestly, now that I'm vaccinated, like one of my favorite things now is not feeling like I need a mask when I'm around other vaccinated people. So I still wear a mask when I'm out in public spaces, or if I'm like in an enclosed area where I don't know the vaccinated status of people, just until the science comes out that like definitively is going to tell me that my risk of spreading COVID, even if I have it like asymptomatically as a vaccinated person, is less than 5%. But yeah, outside of that, like you were commenting on some of my videos, like playing basketball, go out and play hoops. All of the med students are vaccinated here. So we just had like a little like 30-person get together with like everybody vaccinated, which it's been great. It feels really nice to feel safe and good for myself and like also the community and like really get back to normal.
So I heard this. I don't want to call it a myth because it might be true. I'm asking you. I heard this theory, I guess, that from my friend who just had a newborn, and they said, and she's vaccinated, and they said that he might get the antibodies from the breast milk. The doctor said that. Is that true?
Yeah, I've heard that as well. So, I mean, that's a common way that antibodies are passed on to newborn babies. So, we were talking about having immature immune systems, right? So, their immune system hasn't developed yet. They haven't been exposed to all of these things. And so, one way that we naturally have evolved to protect our young is that mother's milk carries antibodies that can be transferred over. So, that's also why, like, they suggest breastfeeding parents get like the flu shot, right? So those antibodies also pass over into the baby. The difference is those antibodies are transient. So they're not the baby's antibodies. So they just kind of float around until they're gone. Whereas when you get like a vaccine, you actually have the cells. So there's cells in you called B cells. And those B cells are the immune cells that make your antibodies. And then there's T cells, and the T cells are the ones that will go and like attack and kill things. And so when you have immunity, you have the B cells that make the antibodies inside of you constantly, and the T cells that can go out and kill the things that are labeled with those antibodies. Whereas like if I just give you, like there's the monoclonal antibody treatments that you might have heard about, which is essentially the same as like transferring antibodies through mother's milk. So that's just taking somebody else's antibodies, not those B cells, and putting them in you. So they'll do a little bit of work, but then once they leave, you're susceptible to getting infected again because you don't have the cells in your body that know how to make those.
Does that work with like anti-venom and things like that too?
Uh, I'm definitely less familiar with anti-venoms and things like that. I think that there is antibody cocktails for that, though. I'm not positive, so this is definitely just me thinking off the top of my head. But yeah, I think if I remember, like as a kid watching the Discovery Channel stuff, like yeah, they like take the venoms out and then they try to make antibodies and like chemicals essentially that will recognize that and neutralize the venoms, which is the same idea, right? But I don't think that people have like B cells, anti-venom B cells in them, but I could be wrong, and that would be amazing. I would change my field of study if that was possible.
So one of the things that fascinates me, especially with like anti-venom and venom in general, is that one of the theories of why we develop such good eyesight, such keen eyesight as primates, as humans, is because when we were coming down from the trees and when we were in the trees, snakes would eat us. And so we were like, that's why a lot of people are afraid of snakes. Now, I don't know if this is true, but I've heard it, and that, so we had to develop really good eyesight so we could look out for snakes. And so something that, fascinates me is how scared of snakes people are. You know, not everybody is afraid of snakes, but most people, some people really like snakes and they have like snakes to themselves. But a lot of people, like, you hear that. I live in southern Nevada, and you hear, you know, you're frozen, you're a prey animal. And so to think that we could have developed as primates, as humans, our eyesight could have gotten better because of that, because snakes would eat us, is fascinating. And I've always thought about too, like, you probably don't know exactly what venom is, but do you know how like animal bites work? Because we were talking about dog bites and rabies and how viruses can transmit. But do you know anything about venom and how that works and how it deteriorates your skin and things like that?
Uh, Oof. I mean, not enough to be really have a really interesting conversation with like all the science behind it. But yeah, they're forms of toxins, right? And so like a lot of the venoms that like snakes and stuff will have are neurotoxins, and I don't think it's just snakes actually. I think there's some parasitic wasps that do this too, maybe some spiders even. A lot of them are neurotoxins though. And so we were talking about your nervous system earlier, and your nervous system controls everything essentially. Your brain thinks things, and that's how like I can talk, is my brain sending a signal down to my mouth that's saying move and like make my vocal cords do this. That's all your nervous system. My nervous system's also doing things that I don't have to think about, like breathing. Like I'm not constantly thinking like diaphragm, flex, pull in air, unflex, push it out. If I had to do that all the time, I wouldn't have time to work on a PhD. But so a lot of these things, there's chemicals that all of your nervous system talk back and forth. So like dopamine, you've probably heard of, serotonin, GABA, glutamate. These are all different types of neurotransmitters, little chemicals that your brain uses to talk to each other. And so a lot of these venoms or some of the cool venoms that I'm aware of, like, I don't know, the blowfish toxin or whatever, they interfere with that signaling, and so they stop your body from being able to do things. And so a lot of times people will die because they like end up suffocating, because if your brain can't send a signal down to your diaphragm to breathe anymore, well then you can't get oxygen in and you end up dying. Or if it gets into your heart and your heart's pretty cool because it has its own like little battery pack that has its own electrical signals. But if it starts interfering with its ability to send those signals, then your heart stops pumping, which is also not good. And that's how you end up dying. The necrosis stuff is pretty crazy. Like I'm terrified of, what are they, brown recluses here in the Midwest. Like when they bite you, I have one of my high school friends' dads got bit by a brown recluse. Like got bit. He's a big guy, like, I don't know, 6'6", 300 pounds, like big beefy arms. And he had like a crater, like probably the size of, I don't know, like a racquetball, like out of his arm. And it was just like, it was covered in iodine, I remember, but like the skin just like started necrosing. So it just like started like dying and eating away. And I have no clue what causes that, but it was terrifying. I was like, I hate spiders. I hate them so much now.
Yeah, brown recluses, and I mean black widows aren't that bad. I mean they're bad. Don't get me wrong. Black widows are not good. Don't go out and get bit by a black widow. But brown recluses, I've always heard, are bad to get bit by, and vinegaroons too. What fascinates me about the vinegaroon is that I hope I'm saying it right. Is that as you get bit, you taste vinegar for like a while after. Yeah, it's fascinating, right? I don't know how that happens. And it's crazy that we don't have venom. Like, why can't I bite someone and then they just like they taste vinegar? No, I'm not. But you know, science fascinates me. And one of the things that fascinates me that you brought up was the battery pack of the heart, right? We got into this last time. We can go back into consciousness as much as we want, but the battery pack of the heart. I was wondering, um, when you go brain dead, right? How
Mhm.
are you still alive? Because it seems to me if you're brain dead, your brain can't send the signals to your heart to keep pumping, or you to keep. Now, breath is a lot of the times on a ventilator, but at least for your heart to keep pumping, right? Why do you know anything about why when we're brain dead we're still alive?
Again, outside of my expertise. So we are definitely just in like having fun chats right now.
Yeah.
But yeah. So one thing is that your heart, like I said, has its own like little essential like battery pack. There's a little spot where the signal starts and it sends out an electrical signal that allows for your heart to fibrillate and pump. And that's partially autonomous from your brain. So like your heart can keep pumping even after you are brain dead, but also like as an athlete, I'm sure you know this, like you can also send signals to your heart to like slow your heart rate down, right? So it's not like completely by itself. It's not like the heart's doing its own thing. If you're like really hyperventilating and your heart's pumping, you can like, okay, focus on my heart rate, feel it slow down, right? So it's linked, but not completely linked. I don't know enough. When I think brain dead, there's two parts of the brain that I also think of. And so you've got your amygdala, which is like your basic animalistic functions. And like also it's like a lot of like keeping you alive, like regulating your body temperature, regulating your heartbeat, your breathing, the things that you don't focus on to stay alive. And when the rest of your brain, the main part of your core frontal, I don't know, the whole thing, cortex, cerebellum, whatever it's called.
I think it's the cerebrum and cerebellum. I think there is two parts.
So the rest of the parts that like do the actual thinking, right? Like process hearing, memory, your personality and all of that. That's normally what I think of like with brain dead, but like the core parts that like you need to keep yourself alive. I don't know if you stay alive without that, but without machines.
These are just two guys talking now.
Yeah. Do not have a medical degree. So
What I will say is this. We got into this last time and I want to get into it with you again because it fascinates me. Personality is something that blows my mind because you brought it up. Personality. Is it all in our brain, Because it makes me wonder because like there's nurture versus nature, obviously, but mannerisms are something that is entirely body almost. And I think there is mannerisms can be a little bit of DNA and a little bit of nurture, I don't think you necessarily always learn the mannerisms of your father because they might have learned it from their father, right? So it's like almost like this genealogy of your whole family of like personality and who you are. And so that's why it fascinates me because back to what we were saying last time, if you make a stem brain and put it in my body, would it be me? Would I have my own personality? Because I think that is an argument against it being you. It'd almost be a robot me that knows what to say and knows how to act, but it wouldn't be me, right?
yeah, I mean, I'm pretty sure the last time we had this conversation, I was on team. It would not be you.
I think you were, yeah.
Yeah, and I think that you just made an argument for my side, so I'll take it. But I do agree with you that like some mannerisms, though, I do think are more so genetic. So you're saying something that really just made me think of like my own life. So I grew up with a single mom. My dad was in the picture. He was in and out of jail my entire like youth. So I didn't really know him, didn't really meet him. And I remember I'd be like in middle school and like being a rebellious teen and like yelling at my mom about something. And she'd be like, you look just like your father when you do that. Like I'd like make these faces where I'm like,
Yeah.
And then like when I met my dad later on in life and like I started building relationship with him, I would see him do these things that like I did. And I was like, you can't, that's my thing. Like I do that thing. He's like, no, I've done this my whole life. I'm like, I don't know where I would have picked that up from. Like it just was a part of me, something that, so like that's a crazy argument for like, it's just something from the genes, I guess, because I couldn't have learned it from him.
It's a crazy argument too for the idea that like collective energy and collective like person, like if you exist for even a small fraction of a second, okay, maybe you need a little bit more time than that, but on the grand scheme of things, a small fraction of a second, your influence has made it to at least your family. And then if you've been alive at least 20 years, at least beyond your families, that when you do die, there is enough influence that you have made to assume that your existence mattered. That crazy, right? It's a crazy philosophical thought. I'm getting in a philosophical train, but to think that no matter what, because of mannerisms, because of your personality, you're going to influence, let's just say 10 people a year, right? We can talk about your family, friends, 10 people a year. You influence 10 people a year. New people, let's go new people, right? Or new mannerisms, new actions. If you have 20 years, again, math, that's 200, right? 20 years, 10.
Yeah.
200,
right.
yeah. Yeah, 200 people. That should be easy, Colin. 200 people after 20 years. If you're 20 years old, that's 200 people. If you're 30 years old, that's 300 people. You live 70 years, that's 700 people that go to the 10 other people. And you do that long enough. This is the thing I was saying. You do that long enough, you take that many mannerisms or personality, you give it to someone else long enough, everybody's connected. And I think we were talking about that last time, is that we're living this interconnected world where everything you do matters in such a way that but it also doesn't matter because everything's connected. You know what I mean?
I mean, that was big full circle philosophical picture right there. Everything matters, but nothing matters. That's how I live my life.
That's how that's how we all try to live our lives. But do you understand? Like, isn't that, it's really crazy to think that we live in this interconnected world where you never know who's really influencing you or who you're influencing.
Oh yeah. I mean, I almost wore the sweatshirt tonight. I have it as you're like talking about this. So my grandfather had a saying that I really love that I think will eventually become another tattoo. For right now, I just made it into a sweatshirt, but it's a life is only worth the number of lives that it touches. And like, I really love that, like that whole philosophy, because yeah, you never know whether it's not like if it's you giving $1 to the homeless person on the street and like that dollar goes to make a difference, or somebody watches you do that and then they go and buy somebody Starbucks, or also the other way around though, like, you know, you push a kid down on the ground and like somebody else sees that and thinks that bullying is cool or something like that. Like your impact, your life, I think is measured by the impact that you have on others. And like personally, I live by the philosophy of I want that to be a positive impact over time. But yeah, I think that that's very true. Like whether it's big or small, you do have an impact on those around you. And if you're morally conscious, you try your best to use that in a good way.
It becomes a thing where I think that's kind of a problem with famous people, is that I think they have to live with that understanding that they influence or impact so many more people than just the normal average person. Because if you keep going down the line, your influence goes to everybody, like we said. But if you're a famous person, you don't have to go that far on the line to see where your influence leads. Especially someone like Joe Rogan, who has one of the biggest podcasts in the world. He speaks to basically everybody. Or you can go any musician who's like huge, Drake, I guess you could say. His, you know, what he says in a song, it's immediately going to affect probably a whole generation. And so, you know, it becomes, the life is only, like your grandfather's saying, the lives it touches. And because you can make an argument that if you're touching people in a bad way, it sounds bad. Don't touch people in a bad way.
Yeah, you should cut that one out.
Don't touch people in a bad way. I'm not advocating for that. Touching people in a bad, if your influence is impacting people in a negative manner, there we go.
There we go.
Then if you really sit down and like understand who that's influencing the whole world, I think you'll have a bigger picture of what humanity should be really about, you know?
I 100% agree. That's the life, the motto, the way.
Let's take it all back full circle and talk about viruses again. You could say the same thing about viruses, right? Like, or an argument for why you should get vaccinated is that influence can be shown through like the way ideas, like the information. I think we're in the information age right now. I tweet something, the whole world can see it if it blows up. But to take that to viruses, if I go out and I sneeze on 4 people and I have COVID, the same thing could be said about spreading COVID, you know?
Yeah, no, early on in the pandemic, I equated, somebody said that COVID was like the new STD, and I was like, that's pretty funny. Like, yeah, nobody wants it, and everybody looks at you like funny if you have it. But I equated it to drinking and driving, right? Like, if you don't want to protect yourself, that's cool. That's your prerogative. Just like if you want to go get hammered and like just black out, that's also cool. Like, that's your prerogative. If you die of alcohol poisoning, like that sucks. It's going to affect the people who love and care about you, but you made that decision. But the second you decide to get into a car when you're blacked out and you hit somebody, I unfortunately have had 2 very two people in my life who were killed by a drunk driver. So I directly know like what the impact is of that. Like they didn't make that decision. So you made this decision. And now not only is your impact that you just killed somebody, but now it ripples and it affects all the people who knew that person and everything. And so COVID, anytime you're sick, but yeah, COVID, I thought was the same way, right? Like if you don't want to protect yourself, you don't want to go get vaccinated, you don't want to wear a mask, whatever, like if you get it and you're asymptomatic, that's great. You get hospitalized, that sucks, but like you were willing to accept those consequences. But if you go and spread it to somebody and it kills somebody's grandma or it hospitalized somebody and now they've got hospital bills to pay for, like you're impacting other people's lives in a negative way, and that's really uncool.
Well, first and foremost, I'm sorry. I'm really sorry that that happened to you, your friends passing away. Um, but second off, I don't think a lot of people understand the expenses of hospitals either. Like, if you really want to just start with that, like people, like I'm law clerking for a law firm this summer because I want to go to law school, do all that thing. But he works in medical malpractice, and to see those hospital bills blows my mind. And that's unfortunately why when negligent actions happen, why people have to sue against those doctors, because not only do they, maybe the insurance doesn't cover the entire cost, but they racked up so much fees, especially if they got hurt while in the hospital. And people don't understand how expensive medical care, especially in the United States, is, especially for good care.
Yeah, it is really expensive. And it doesn't help that while I have all respect for doctors and physicians and medicine, modern medicine, the hospital system itself is a supermarket for people. Patients have price tags, and that's why doctors complain about not having enough time for patient interaction and stuff like that. And so the hospital is at the end of the day an entity to make money. And so, you have to get a ambulance ride, and that's couple $1,000 right there just for the ride to the hospital. You didn't even get treated yet. They give you an ibuprofen on the ambulance, and that's $500. I don't know why that I made that number up. But I assume that an ibuprofen is probably more expensive in the hospital than it is if you get it in the pills that you have it. But all these things build up, and so anytime you don't have to go to the hospital because you're dying over something, again, let me clarify, I'm not advocating not going to the hospital if you're sick. But if you have to go to the hospital, not only are you going there because you're sick, because your life might be in danger or something like that, but you're also adding a hospital bill, like you were just talking, on top of that. And so not everybody's fortunate enough to have good insurance. Not everybody's fortunate enough to have finances where, just getting a couple $1,000 hospital bill is like no big deal. That can be crippling to somebody if they have to choose between paying a bill, going into default, or feeding their family.
Yeah, it's like that Family Guy episode where he's when he's still walking, he runs in on, he's chasing a shoplifter, and he's just trying to feed his family with, I can't remember if it was an apple or soup, and he just lets him go because it's like that's like when your humanity starts to tap in, when people start to steal to feed their family. It's like, what are we
That's
doing?
ridiculous.
It's
Yeah.
like, what are we doing? And unfortunately, that's a lot of the way the American civilization is founded on, is entities make money, like you're saying. Hospitals alone make money because they're hospitals. And then you can go airports. Why are a bag of chips at the airports $15, dude? I'm just trying to fly. Um,
Exactly.
and it's because the entities like making money, and they
I
gotta
mean,
play. No, what were you gonna say?
oh no, sorry, I didn't mean to interrupt you. Go ahead, finish up.
I think I was finished. I was just gonna say entities. They especially in American society, we have to make money, or we want to. You know.
Yeah, I mean, I am not here to condemn capitalism. I'm all for it. I love being able to make more money based off of selling a product or having something that's useful. I mean, I don't make any money right now, so hopefully I'd like to have a product that's useful, but I like the idea of being able to do that. But the downside of capitalism is that you just have to assume that capitalism without morality is evil. I mean, essentially, right? Is you're just going to make money. You're going to put profit over people, and you're going to make money on the backs of others and put them down. So I think there needs to be a balance in any corporation, any spot in capitalism where you have to weigh morality with the benefit, right? How can we make money? How can you be rewarded for doing a service, But how can you then take that and stick a hand back and pull those behind you who have less up, and like do your part for humanity? Be a good person and make money. Plain
Yeah,
and simple.
I think it's fascinating what you're saying, because it's almost like one of the problems with especially our capitalist system is that it's a bunch of different morality compasses acting together, and some people believe one thing and some people believe in the other. And so when they're all fighting everything, and only thing that really regulates them is some governmental plans, but really the free market, you can basically, companies can run the world. Large corporations get to run society. Basically, they get to deem what the price is to be paid for something. And so, like I said, I like to think that most people are good people, but I don't know if that's the case for all corporations, because it's a combination of people.
Yeah, yeah. I mean, I don't know. And it's easy to see, I don't know. I don't know if it's money or what, but like this makes me think of like Facebook and things like that, right? Where like it starts out as something innocent, and like all of a sudden like what it's become, I don't know. Is it because Facebook is an evil entity and they're just like, they don't care? Or is it that they're about the bottom dollar, so they don't care what's being put out there? Or is it just the fact that like, they're not evil and things just get ahead of them and they don't know how to keep up with it? And so, yeah, who am I to pass judgment on everybody out there trying to make a buck? But it'd be nice if more people put people over profit than the other way around.
For sure. Well, I think that was a good conversation, Kennen. Is there anything you want to talk about before we wrap this up?
Uh, I don't know. We hit a lot of different topics here. Everybody's got herpes. I forgot to tell you the numbers here in America between the ages of 14 and 49. Um, 2 out of every 3 people have herpes, so 66%. So if you're in a room with 3 people, 2 of them have HSV1. 1 in 8 people have herpes simplex type 2. So if you're in a room with 10 or 8 people, 1 of them has HSV2. 98% of people have chickenpox virus, which later becomes shingles. That's why you have to get the booster. So pretty much everybody has that. And then if you've ever had mono, that's also a herpes virus, Epstein-Barr virus. So everybody's got the herp.
Everybody's got the herp. Well, man, this is always fun talking to you. You're very engaging. We always have a good conversation, and I think we cleared up the vaccine argument for everybody. So
I hope so. We definitely went off track on that. But yes, I'm not going to tell somebody to get the vaccine, but like get the vaccine. Like